Hi everyone! Today we're going to be talking about colligative properties. So first, what is a colligative property? Well, it's a property that depends on the amount of solute dissolved in a solution. And there are four colligative properties we're going to be talking about today. The first one is osmotic pressure. So osmosis is the diffusion of water through a semi-permeable membrane in order to make the concentrations of solute equal on both sides. So if you can imagine, you can have a membrane and you can have some amounts of solute on both sides, right? And let's say you have more solute on one side, then there's going to be water that's going to move from side to side in order to make these concentrations equal. So as you can probably imagine, there's going to be a force exerted by this water moving through a semi-permeable membrane to a more concentrated area, and that force is going to be osmotic pressure. So why is it a colligative property? Now that we know what it is, why is it a colligative property? Well, if you can imagine, if you have a membrane with a lot more solute on one side than another, you're going to need a lot more water moving to that side in order to make these concentrations equal, and therefore there's going to be a lot more force exerted by all this water moving to the other side compared to if these concentrations were almost equal on both sides and there's just a little bit of water moving, the force isn't going to be that strong, right? So that the greater the solute, the greater the disparities in solute, the greater the osmotic pressure is going to be, which is going to make it a colligative property. So the second colligative property we're going to be talking about is going to be vapor pressure depression. So first, what is vapor pressure? Well, it's a force of the liquid particles trying to push up into the gaseous phase, right? So let's say we added some solute to a solution. What would it do to vapor pressure? Well, if you think about it, if you added a bunch of solute to a solution, you would actually, on the surface of the solution, right, a lot of these solute particles will be taking up space. So now that when these solvent particles are trying to push up into the gaseous phase, it's harder for them to do so because all of these solute particles are taking up space at the surface and all around. So it's going to decrease the rate at which these solvent particles are being able to escape up into the gaseous phase, right? And if it's decreasing the rate, it's also going to be decreasing the vapor pressure. So when solute is added to a solution, it actually decreases the vapor pressure because it's slowing down the rate at which the solvent particles are able to escape the solution and therefore decreasing the vapor pressure. So hopefully that makes sense. If that's kind of confusing, please let me know below or send me an email and I would be happy to explain it further or again in a different way. So now the next two colligative properties we're going to be talking about both link back to vapor pressure depression, right? And they kind of go hand in hand and you'll see why. So the third property is boiling point elevation. And we're going to say that when a solute is added to a solvent, it will raise the boiling point of that solvent. So for example, if you've ever tried to make pasta or something and you put salt in the water, you would see that it would boil at a higher temperature. And the question is why, right? So this links back to vapor pressure depression actually. So let me just write that in. So if you remember back to the changes of state, and if you don't, we definitely have a video on that, so you can go check that out. But if you remember back to changes of state, we talked about how both the pressure and temperature are vital or both play a role in changing state, right? So if you're going to decrease the pressure, then you're going to have to increase the temperature in order to get it to boil. And if you also think about this logically, right? So if you have all these solute molecules blocking the top and the solvent molecules are having a harder time or a slower time getting out, you're going to have to increase the temperature in order to make it boil to compensate for the decrease in pressure, right? So hopefully that makes sense. If not, I can always explain it again if you just leave a comment or email us. And the fourth one, which again goes hand in hand with vapor pressure depression and is similar to boiling point elevation, is freezing point depression. And we're going to say that when a solute is added to a solvent, it causes the freezing point of that solvent to decrease. So again, it's linked to vapor pressure depression. So if you think about it this way, let's say you have two solvent molecules right next to each other, and if you decrease temperature, they're going to slow down and sort of stick together. But let's say you have these two solvent molecules, but now you have a solute molecule in between them. Then you're going to have to decrease the temperature kind of even more, right, in order to get them to stick together and become a solid. So that's kind of a logical explanation as to why you would have freezing point depression. And then once again, you can also think about it in terms of vapor pressure, right? So if you're going to decrease the pressure, then you're going to also have to decrease the temperature in order to get it to freeze. So hopefully that makes sense. These are the 4 colligative properties we talked about, and I hope everything made sense. If not, feel free to email us or leave a comment down below, and I would be happy to explain anything else to you or re-explain some of this. Please like and subscribe if you enjoy this video, and have a great day. Thank you.